Exponential and logarithmic equations. The previous lesson we learned several definitions and rules about logarithms, and so now we're going to apply those rules to solve equations, and we're going to round all of our answers to 4 places. So first let's start thinking about if we wanted to solve the equation 3 to the power of x equals 9. Hopefully you could just do that in your head. You know that 3 squared is 9, so x is 2. However, what if we needed to solve the equation 3 to the x equals 14? That's not going to be an integer value. That's not going to be something you can just think about in your head and come up with and solve. So this is the type of problem we need logarithms to solve. Our first one we're going to do is solving 10 to the power of x equals 14.3. If you recall from the previous lesson, one of the rules was log base a of a to the c equals c log base lowercase a capital A. And so the point of that rule is that if you're taking the log of something with an exponent, you can move the exponent to the front. So since we don't want this x to be an exponent, if I put log in front of it, because of the rule, I can move this exponent out to the front. But you can't just put log on the left side. Whatever you do to the left side of an equation, you have to also do to the right. So I'll do log on the right side as well. Now I have x log 10 equals log 14.3. And then we'll divide both sides by log 10, which actually is just 1, but then you can put that in your calculator, and we'll round it to 4 places. We get x equals 1.1553. Kind of a cheesy way to remember that this is what you do. If you don't want an x floating in the sky, you smack it down with a log, like a tree log. Get it? It's hilarious. But that might help you remember. The next one is 10 to the power of 5x minus 2 equals 348. Again, we don't want that 5x minus 2 floating in the sky, so we'll do log on both sides. And that will make the 5x minus 2 move out front. Now, because the entire thing is out front, we need to put it in parentheses. Parentheses 5x minus 2, and then log 10 equals log 348. Now divide both sides by log 10. 5x minus 2 equals log of 348 over log 10. Don't put anything in the calculator till the very end, because the more you round, the more inaccurate the answer becomes. Now let's add 2. 5x equals log of 348 over log 10 plus 2, and now divide by 5. Now because we've got a lot of stuff on the right side and it all needs to divide by 5, I think it's a little bit easier to write it like this. X equals, because you'll need these parentheses in your calculator, parentheses log of 348 over log of 10 plus 2, close the parentheses, so that set of parentheses tells the calculator that all of that gets divided by 5. And so then in your calculator, rounded to 4 places, we get x equals 0.9083. E to the negative x equals 0.0142. The inverse of e is natural log. So if I need to get rid of e in an equation, I apply natural log to both sides. So natural log on the left side, natural log on the right side, the natural log and the e cancel each other out. And we have negative x equals natural log of 0.0142. Divide both sides by negative 1. So x is negative natural log 0.0142. And then that goes in your calculator to 4 places, 4.2545. 13 plus e to the power of 3x plus 5 equals 23. Before you can natural log both sides, you need to get the e by itself. Subtract 13. E to the 3x plus 5 equals 10. Now I can do natural log on both sides. 3x plus 5 equals natural log of 10. Subtract 5. 3x equals natural log 10 minus 5. And then all of that gets divided by 3, so I'm going to put it all in parentheses. X equals parentheses natural log of 10 minus 5, all of that divided by 3. You need those parentheses in your calculator. X is negative 0.8991. 50 over 1 plus e to the negative x equals 2. So now that e is in the bottom, we don't want it in the bottom. You can get it out by multiplying both sides by the denominator. 1 plus e to the negative x. 1 plus e to the negative x. So the 1 plus e to the negative x cancels with the one on the bottom. 50 equals 2 times 1 plus e to the negative x. Now, you could distribute the 2, or you can just divide the 2 out right now, which is what I'm going to do. 25 equals 1 plus e to the negative x. Subtract 1. 24 equals e to the negative x. Now that the e is by itself, I can natural log both sides. Natural log of 24 equals negative x. Divide by negative 1. And then put that in your calculator. X is negative 3.1781. This one's a little bit different, but it can actually be factored because the e is squared and then the next e is just to the first power. So I can look at the negative 4 and get factors to make negative 3. That would be a negative 4 and a positive 1. And the e to the 2x will be split up into e to the x, e to the x, just like it were an x squared would split into x and x. Now that it's factored, I set each term equal to 0. And then we're going to solve each one. So add 4, e to the x equals 4. Natural log both sides. X is the natural log of 4, which is 1.3863. On the other one, we're going to subtract 1, so e to the x equals negative 1. Natural log both sides. Now, if you put that in your calculator, natural log of negative 1, you get an error because the natural log or the regular log of negative or a 0 are undefined. So let's kind of make note of that. Log or natural log of anything less than or equal to 0. So that would be 0 and then all the negative numbers are undefined. So you can't take the log or natural log of a negative number or of 0. Natural log of x minus 4 equals 2. This time we're starting with natural log. So to get rid of it, we're going to have to do e on both sides, and it will become e to the power of natural log of x minus 4 equals e to the power of 2. That's a little bit different. On the left side, the e and the natural log cancel each other out, and we have x minus 4 equals e squared. Add 4, e squared plus 4. And e on your calculator is usually right above the natural log button. Put that in your calculator, round to 4 places, 11.3891. Log of w plus 2 equals negative 2. The way you do this is rearrange the problem into exponential form, which we did a couple of lessons ago. And so we need a little base to grow up and become a big base. Remember, if you don't see a base at all, that there's an understood 10. So our little 10 grows up, becomes a big 10, and then the negative 2 and the w plus 2 switch sides. So we have 10 to the negative 2 equals w plus 2. Subtract 2 from both sides. Then that goes in the calculator, and it's negative 1.99. That one's hard to remember from time to time how to do it. Now, when your original equation has log, L-O-G log in it, you need to check your answer to make sure if you plug it back in the original problem, you're not trying to take the log of 0 or a negative number. So you have to check. When I try to put negative 1.99 back in the original, negative 1.99 plus 2 would come out positive. So we're okay. That solution we can keep. Log of x plus log of x minus 1 equals log of 4x. So from our logarithm rules, we can combine the logs on the left side. When you have addition, you can squish that back together into multiplication, and you have log of x times x minus 1 equals log of 4x. Now there's another little rule. Well, let me go ahead and distribute. There's another little rule that says if you just have a single log on the left side and a single log on the right side, you can cancel those out. There's nothing added or subtracted on the front or back of those logs, so they can go away, and we have x squared minus x equals 4x. It's a quadratic, so we want that all set equal to 0. Subtract 4x. X squared minus 5x equals 0. And that factors, I can pull an x out. Now set each term equal to 0. We have x equals 0, x minus 5 equals 0, so x would equal 5. Now, I said just a second ago, if you have log as part of the original equation, you've got to check your answers to make sure when you plug them back in, you don't end up having log of 0 or a negative. When I plug 0 back in, right away, I see I have log of 0, which can't be. So x equals 0 has to be thrown out. If I try the 5, everywhere I see an x, I don't end up with log of 0 or log of a negative number. So 5 is the only solution. Use a graphing device. Some textbooks call graphing calculators a graphing device to find all solutions. So we're to solve this with a calculator. Natural log of x equals 3 minus x. So the way you'll do this is when you push y equals on the calculator, in y1 you'll put what's on the left side of the equation. In y2 you'll put what's on the right side of the equation. And then when you graph it, you can just use the zoom standard window for this. You can see the two graphs intersecting. The natural log of x is the one with the curve. 3 minus x is just a straight line, and we want to know where the two lines cross each other. So if you have the iPhone, you just touch where they cross each other and you'll get the solution. Otherwise, you have to push second, trace, intersect. 2 right there. And then you hit enter 3 times. The x value of the intersection is the solution. So the solution is x equals 2.21. Make sure you look at your notes for some special instructions and homework windows.